Hi guys, today let's discuss the LeetCode question 64, minimum path sum. This is also going to be a dynamic programming question. So this question is about given an m cross n grid filled with non-negative numbers, find a path from top left to bottom right which minimizes the sum of numbers along its path. So we have to move from top left to bottom right in such a way that the numbers along this path, the sum of the numbers along this path is minimum. Okay, and the constraint to this question is you can only move either down or right at any point of time. So from this first grid element 0 comma 0, you can only move to 0 comma 1 or 1 comma 0, and you cannot move to 1 comma 1, which is a diagonal element. You cannot move in that direction. Yeah, so let's go to the constraint section as well. So in the constraint section, we are given m is equal to grid dot length. So the length of that grid is greater than or equal to 1, and the number of columns in the grid is less than or equal to 200. So which means that m and n are greater than 1 and less than or equal to 200. So if you look at, so let's look at the two examples. So the first example is in the example 1, we are moving along the row horizontally first and then vertically. So we are moving along this path 1 3 1 1 1. So the total path sum is 7. In the second example, we are moving along 1 2 3 and then 6. So the output is 12. Yeah, let's go into the explanation part of it. Hi guys, we are considering the example 1 that is provided in the question, and the output for this example is 7. So the output is along this path. So let's update these grid elements with the minimum path sum that is reached from the top left. So the first thing that we are going to do is for 0 comma 0, we are going to maintain the same value, which is 1. And for 0 comma 1, we are only having one path where we can move. So we are going to add up this 1 and 3. So it is going to be 4. And for the next one, 0 comma 2, there is only one path, and the minimum path sum is going to be 1 plus 3 plus 1. It is going to be 5. And for 1 comma 0, there is only one path, which is coming from 0 comma 0. So the output is going to be 2. And if we are considering 1 comma 1, there are two paths which 1 comma 1 can be reached. So we have to consider the minimum path. So we are going to consider the minimum value of this 4 and 2. So the minimum path is going to be 2, minimum path sum 2, plus the current element, which is 2 plus 5, that is going to be 7. And for 1 comma 2, which is this element, there are two possibilities again. So if you are looking at the minimum value, it is going to be 5. It is going to be 5. 5 plus 1 is going to be 6. And for updating 2 comma 0, there is only one path. So we are going to add up 2 and 4, that is going to be 6. And for the next element, for 2 comma 1, it is going to be the minimum of these two values, 6 and 7. So we are going to consider 6 since it is minimum, and we are going to add 2 to it. It is going to be 8. And for the last element, 2 comma 2, there are two possibilities. Since the 6 is minimum, we are going to add 1 to it. So this is 7. And finally, we are going to return 7. So let's look at that the explanation part of it, how we are going to code this on up. So the explanation. So the first thing is, if I equals 0 and j equal to 0, so which means that this is a starting element, then do not update grid. Don't update grid. 2, if I equal to 0, which means that this is the first row, then grid of ij is equal to, we can say grid of ij plus equal to grid of I minus 1, it is going to be I and j minus 1. I and j minus 1. And the third step is going to be if j equals to 0, then grid of ij plus equal to grid of I minus 1 and j. And the fourth step is when I is not equal to 0 and j is not equal to 0, then grid of ij plus equal to minimum of, okay, let me write this one at the bottom, equal to minimum of grid of I j minus 1 comma grid I minus 1 and j. Yeah, it is very clear from this explanation. Let's quickly code this up. First, let's look to the entire grid for I in range of length of grid, for j in range of length of grid of 0, and if we are encountering the first element in the grid, top left element, I equals 0 and j equals 0, j equals 0, then we'll just do continue. We are not going to update any this element. And if I equals 0, then grid of I j plus equals grid of I and j minus 1. So we are going to add this one because that is the only way we can reach this grid of ij. And if j equals 0, grid of ij plus equals grid of I minus 1 j. So this is the only path that we can reach, so we are adding that path. So let's make this one as else if, and this is the else condition. So else condition is for the rest of the elements which do not belong to the first row or the first column. So in that case, grid of I j plus equals, it is going to be the minimum of, there are actually two possibilities to reach this grid. So it is going to be the minimum of grid of I j minus 1 comma grid of I minus 1 j. Yeah, we have updated the grid. So what are we going to return? We are going to return grid of the last element, the bottom left element. So minus 1 and minus 1. So let's run the code. Yeah, let's quickly submit it as well. Yeah, it is submitted. I hope you like this video. Like and subscribe to my video. Thank you.